This lecture will cover what are known as phase transitions and phase diagrams. Okay, so if we have solid, liquid, and gas, so that would be the different phases of a substance. So what are these different phase transitions called? So if you convert solid to liquid, or liquid to gas, right, or gas to liquid, or liquid to solid, so what is that called? So solid to liquid would be like ice to water. That would be melting. Liquid to gas, so water to boiling the water, so that would be evaporation. Gas to liquid, so that would be condensation. Right, like the condensation you would see on your yard in the morning or your window car after it cools off and water becomes less well, what's the word? The air can't hold as much water in it when the temperature cools off, so it'll condense out. Liquid to solid, so water to ice would be freezing. And then there's two more possibilities, right? You could go directly from the solid to the gas phase. So what would that be called? So maybe you know an example. An example would be like dry ice. Right? What is dry ice? It's frozen carbon dioxide. So if you have a block of carbon dioxide sticking on a table, come back a few hours later, there won't be a puddle of water around, or there won't be a puddle of liquid around, because frozen CO2 goes directly from the solid to the gas phase, so that block of CO2 would just be smaller. And that process is called sublimation. And the other possibility is to go directly from the gas phase to the solid phase. And so this will be the least common of them all, and probably be the one that fewest people know. This is what's called deposition. So you find deposition used in the computer industry all the time, for example, where they have to make really pure computer chips, silicon wafers. So they'll take something from the gas phase and deposit it directly onto the wafer through the process of deposition. Okay, so phase changes for different compounds can be represented using what's called phase diagrams. So this will be something that engineers or people who work with materials deal with all the time. What is the phase of something at different temperature and pressure? So the phase diagrams look something like this. On this axis, you have what's known as pressure in a unit of atmosphere, and temperature. You know, Celsius or Kelvin, doesn't matter. So we'll look at a phase diagram for water, for example. So its phase diagram looks something like that. So three different phases: solid, liquid, gas. So which one would be which? So as you go to high temperature, and this will be low pressure versus high pressure. You know, so if you go to really low pressures or low temperatures and high pressures, then this phase of water would be ice, or well, it'd be solid. Whereas if you went to high temperatures and low pressures, then water is going to exist as a gas, and then in between would be the liquid state. Okay, so there's a couple of interesting points on the phase diagram. This point here is what's called the critical temperature and pressure, and this is where a fourth phase of matter exists, what's called a supercritical fluid. So for water, it's difficult to achieve that because you have to go to 374 degrees Celsius, so quite high temperature, and you have to go to around 218 atmospheres, so extremely high pressure. So it's hard to conceive of what a supercritical fluid is. Like we can all conceive of what a solid is, what a gas looks like, what a liquid looks like, but what does a supercritical fluid look like? So it's hard for me to have a mental picture of what that looks like, but it's basically, it's a phase of matter that flows like a gas, but dissolves things like a liquid would. So for water, not a lot of practical applications of supercritical water because of the high pressure and high temperature you have to go to. We'll look at an example in a minute of CO2, and it has supercritical CO2 has lots of practical applications. Okay, so this point on a phase diagram is what's known as the triple point. It's simply the point where solid, liquid, and gas phase of water all coexist simultaneously. Okay, so what you might have to do on a test, for example, is I tell you, for example, let's say you start at point A and you decrease the temperature and go to point B. What's that phase transition called? So A to B would be going from gas to liquid. So that would be condensation. Or if you're here at point C and you went to point D, right? What's that called? That would be called sublimation. Okay, so this would be, so phase diagrams for lots of different compounds are known, and basically they're published in tables so that anybody working with different material can just look and see at specific temperature and a specific pressure, what is the phase of that matter? Is it a solid, is it a liquid, or a gas? Okay, so let's use this to explain another little concept on how to dry something. So if you had something that was wet, say you're at point B and you wanted to dry it, well, how could you dry it? Well, the same way that you would typically dry things. What you could do is simply, if you went to B to A, so if you increase the temperature, then the water will evaporate. That would be one way to dry something, but there is another way to dry something. And the other way to dry something would be, you could go from B, you could decrease the temperature. So go to point, I'll call that point E. And then after you decrease the temperature, then decrease the pressure. So you went from B to E, so basically you freeze it, and then you sublime it. And then now you're at point, we'll say point D. So freeze, sublime. Would be what's called freeze dry, how to freeze dry something. So where do you find freeze dry used at? Well, one place it's used in food. So if you freeze the food and then drop the pressure, you can take the water and go directly from the solid ice to the gas phase, and then you pump it off with a vacuum. And so what will be the purpose of that? So you could preserve food better that way with without cooking it. Because if you heat it, of course, you're going to cook the food. So if you freeze it and then sublime the water off, you freeze dry it. So why can it be preserved? So no water. So bacteria can't grow. And also, it'll weigh less at this point, and that has applications, right? So who would use freeze-dried food? Military would use it because it weighs less, so it's easier to pack in. Used in space flights because the food weighs less, it's gonna be easier, less fuel, less cargo weight. If you go camping, you could take freeze-dried food with you. Then when you get to your campsite, what do you do to reconstitute the food? Just add water to it. Okay, so one more example. So for CO2, its phase diagram looks like this. So again, this will be gas at temperature increasing that way and pressure increasing this way. And this will be liquid and this will be solid. So to reach the critical temperature and pressure for CO2, you only have to go to 31 degrees Celsius, so just above room temperature, and only 73.7 atmosphere pressure. So it's much easier to make supercritical CO2 than supercritical water. So one application that it has is to decaffeinate coffee and tea, because caffeine is very soluble in supercritical CO2, so you can put the coffee beans or tea leaves in there and it'll dissolve the caffeine out, and then you pump it away and now you have decaffeinated tea and coffee beans. Okay, and so we're at about 1 atmosphere pressure. So if you just follow this phase diagram across to this point, so at about 1 atmosphere pressure, which is about what pressure we're at, solid CO2 would go directly from the solid to the gas phase, so it would sublime. So at 1 atmosphere pressure, right, so this would be one reason why solid CO2 is dangerous to handle with your bare hands, because you can get frostbite very fast because it's very cold. It's sitting there at any temperature above at 1 atmosphere, negative 78.5 degrees, it's going to be subliming directly from the gas solid phase to the gas phase. Okay, so again, basically, you just have to be able to read a phase diagram. You know, again, if you're simply out of point A and I tell you to go to point B, what phase changes that? Solid to liquid, that would be melting. Okay, that's it for phase diagrams.